So this is video number 2 on solving systems with substitution method. Picking up right where we left off. You and your partner should have worked on this system, followed the instructions below, and I'm just going to work it out to show you if you did it correctly. So step 1 is to pick an equation and to solve for a letter. So do you want to pick the top one or the bottom one? Obviously the top one's the best choice because it already has a letter that's solved. It already has y by itself. So you might as well pick that top one and move on to the next step. Take that variable expression and plug it into the equation you have not used. Okay, so you pick the top one, you haven't used the bottom one. Let's plug it right into the y. Now, why am I not plugging into x? Because it doesn't say x equals. If it said x equals, then I would plug it into x. But it says y equals, that's why I'm going to plug it into the y. And again, I always draw arrows, right? So what I'm going to do here is draw an arrow this way, and I'm going to rewrite my whole equation. 2x minus 3 times y, but notice that I put parentheses because I'm going to plug in my value, my variable expression right in there, equals negative 4. So once again, I am plugging in the negative 3x plus 16. I'm plugging it right in there. And now I could take this and I could solve it. Of course, the first step on solving is to simplify, which means distributive property and combining like terms. So I'm going to take this negative 3 and go negative 3 times negative 3. That's positive 9, of course, with an x. And then negative 3 times positive 16, that's negative 48. And of course, you're going to bring down the 2x that's in front. Bring down the equal sign, bring down the negative 4. So I've distributed. Now all I need to do is combine like terms. So on the left side of the equal sign, there's 3 terms, 2 of which I could combine. I could combine the 2x plus 9x, and you just do this in your head. 2 x's plus 9 more x's is going to be a total of 11 x's. Bring down the minus 48. Bring down the equal sign, bring down the minus 4. Now you want to get x by itself on the left side. So you want to get rid of the 11 and the 48. You get rid of the 48 first. So let's add 48, doing the opposite of minus 48. That'll be 0. That'll cancel out. What you do to one side, you do to the other side, plus 48. So the equal sign is going to come straight down. On the left side, I have an 11x left over. And on the right side, negative 4 plus 48. If I owe somebody $4, but I have $48, I'm going to still have 44 left over. My final step is to get rid of the multiplication of 11 in front of the x. So I do that by dividing by 11. What you do to one side, you do to the other side. X equals 4. Beautiful. We have one answer. We still need the other. How do we get the other answer? You simply plug it back in to any equation you want. I'm going to take this x value of 4. Might as well draw some arrows again. I'm going to take the x value of 4, and I'm going to plug it into the top equation, right into the x position. Could I have plugged in the 4 right here? Yeah. You can plug it in here if you want and solve this equation. But I'm plugging in the 4 on this top one, just because I want to. So let me rewrite the top equation. Y equals negative 3x, but I'm going to put parentheses because I'm substituting the value 4 into the x position, plus 16. Of course, I'm going to put the 4 right in there. And now I'm just going to solve it. It's going to be negative 12 plus 16. Bring down the equal sign, bring down the y. What is negative 12 plus 16? That's 4. So I really have y equals positive 4. So our answer, the x value is 4, and the y value is also 4. Now we've had a couple of systems where, oh, the other answer was 3, 3, this one's 4, 4. That's just coincidence. It's not like it's going to happen like that all the time. Okay, so again, let's have you and your partner solve this system. And it says On this one, you could solve any method you like. You don't have to use substitution. But, I mean, substitution is the best method because graphing is pointless, especially if you don't have an actual graph. So I'm going to pause it, work on it, and then I'll explain it. Step 1, pick an equation and get a variable by itself. See, if I pick the top equation, I'm going to have to do 2 steps. Whether I solve for x or y, it's going to be multi-steps. But if I pick the bottom equation and I choose to get x by itself, all I have to do is subtract 3y. So that's exactly why I'm going to pick the bottom equation and I'm going to solve for x. Okay? So pick the bottom equation. I'm going to subtract 3y. Here it is. X equals negative 3y plus 3. That is step 1. Okay, we picked an equation and we got the variable by itself. We solved for a certain variable x. You could have solved for y, but this was the quickest method, or quickest path. There's many roads to the same place, right? And this is the quickest one, so that's why I picked it. Step 2, take that variable expression and plug it into the equation you have not used. So we have not used the top equation, and I'm going to plug in this variable expression, this 3y minus this negative 3y plus 3. I'm going to plug it in. Where am I going to plug it in? To the x or to the y? I hope you don't say y. I hope you say x. Why am I plugging it into x? Because x equals, that's what it says, x equals negative 3y plus 3. So I'm definitely going to plug it into the x. Why? Because x is equaling this stuff over here. Okay, so let me draw another arrow going this way, and let me rewrite my whole equation. I'm going to write 2x, but instead of 2x, I'm going to put 2 parentheses because I'm plugging in the variable expression in there. And then let me continue, plus 5y equals negative 5. So in there, I'm going to plug in the negative 3y plus 3. And then I'm going to distribute. 2 times negative 3y is negative 6y. 2 times 3 is positive 6. Bring down the plus 5y. Bring down the equal sign. Bring down the minus 5. Now I still have 3 terms on the left side. I'm going to combine like terms. In other words, I'm going to combine the negative 6y with the positive 5y. You can do this in your head. If you owe somebody $6 but you only have $5, you could give them the $5 and you're still going to owe them one of those dollars, in this case one of those y's. Let me bring down the rest, the plus 6, the equal sign, the minus 5. Now from here I need to get y by itself. I need to get rid of that 6 by subtracting 6. My new equation is going to be negative 1y equals negative 11. My final step will be to get rid of the multiplication of negative 1 by dividing by negative 1, dividing by negative 1. So my y value really equals positive 11. Positive 11. Now, I have my y, I need my x. Again, remember, an answer to a system is both the x and the y. So far I just have the 11. I need this missing x value. So I have half of my answer. How do I find the other answer? You simply plug it back in. Plug it back in where? You've already used both of them. You can plug it into any one you want in the original. So I'm going to take this y value of 11 and I'm going to plug it in. You could go right here and get 55, but you'd have to subtract 55 and then divide by 2. And if I plug it in right here, it'll be 33. So I subtract 33 and then I'm done. That's my x answer. So it's wiser, it's a quicker path to pick that bottom one. So let me do that. Let me rewrite the bottom equation. X plus 3 times y equals 3. And we said we're plugging in the 11 right there. So that's really x plus 33 equals 3. And if you subtract 33 on both sides, you're going to get x equals negative 30. Because if you have $3 and you owe $33, there's not enough room to show it. But if you subtract 33, subtract 33, if you have 33 and you owe 33, you're still going to owe 30. So my complete answer is negative 30, comma 11. So substitution was great. Why? Because even graphing would be a horrible idea, because even if you had a 10 by 10 graph, these lines would not intersect till way off the graph at negative 30 on the x and positive 11 on the y. So substitution is great right here. Now, if you have some extra time, all you got to do is plug in your x value into here, your y value into here, and see if it actually gives you negative 5, which it does. Plug in your x value right here, your 11 right there, and it will give you 3. So you could double check any answer you have to a system, regardless of if you did substitution method or if you did graphing. So we have more practice. So let's jump on this. I'm going to pause it right here. I want you guys to try this on your own, but of course if you need help, raise your hand or ask somebody for help. I'll pause it and then I'll go through the answers. Number 4, let's substitute. Step 1, pick an equation. I want to pick the top one. Why? Because it already has y by itself. Now I could just take that variable expression, that y equals, and plug it into the equation I have not used. So I'm going to rewrite this thing. X plus y, but instead of y I put parentheses, equals 5. What am I plugging in there? I'm plugging in x minus 3. Question is there anything to distribute? There's a plus sign. There's nothing there. I mean, technically there's an invisible 1, but if you distribute a 1, it's not going to change anything. It's 1 times x is still x. 1 times negative 3 is still negative 3. So in other words, you don't even need those parentheses. Let's just rewrite the whole thing. X plus x. Again, if you did 1 times x, it's just x. 1 times 3 is just 3, but it has a minus sign, so that's a negative 3 at the very end. Equals 5. Combining like terms, what is x plus x? That's 2x's. So I have 2x minus 3 equals 5. I need to get x by itself. I'm going to go plus 3, plus 3. You're going to end up with 2x equals 8. To get rid of the multiplication of 2 in front of x, you do the opposite of multiplying, which is dividing. What you do to one side, you do to the other side. Final answer is x equals 4. Again, that's half of your answer, the x value. You still need the other half, the y value. So let's take that x value of 4 and plug it back into any equation I want. You could go here, 4 plus y equals 5. You know that the answer is going to be 1. Or you could go up here, 4 take away 3 is going to be 1. See, it gives you the same answer anyway, so plug it into any original equation that you want. I'm going to go with the top equation. Y equals x minus 3. Of course, 4 is x, so I'm going to put it right there, 4. So I really have y equals 4 minus 3, y equals 1. So my answer to the system is the coordinate 4, 1. Moving on. Number 5. This one's so easy that you might get confused, right? I mean, who would want to graph this? Forget that. This is so easy. Why? Because they tell you x equals 2. I mean, they're giving you an answer. Remember, an answer to a system is the x value and the y value, and they're telling you x equals 2. All you need is the other answer. Okay, so all you do to find the other one is take that 2 and plug it in to your x, because x is 2. So let me rewrite the bottom equation. 2 times x plus 3y equals 7. And we said x does equal 2, so you substitute it right in there. Then you just solve it. 2 times 2 is 4, plus 3y equals 7. And then you get rid of the 4 by subtracting 4. You're going to have, cancels, 3y equals 3. Final step to get rid of the multiplication of 3 is to divide by 3. Y equals 1. So your y value is 1, and there's your answer, number 5. Number 6. Is substitution a good idea? I mean, it could be. You could pick an equation, and you could get a variable by itself. Both equations already have y by itself. So you could just take that top equation and take that 6x minus 3 and plug it into the other equation into the y position, because y equals that stuff. So my new equation would be 6x minus 3 equals negative 2x minus 3. And of course you have a equation with x, and you could just get x by itself on one side of the equal sign. You could solve and get your answer. Now, all right, just for funsies, I'll keep going. So let me get the x's on the left side by adding 2x to both. I'll have 8x minus 3 equals negative 3. And then finally, I go plus 3, plus 3. I'll get 8x equals 0. And if I divide by 8, I'll get x equals 0. And that's one answer. To find the other answer, you simply plug in your 0 right up there, or right there, it doesn't really matter. So let's plug it into the bottom one. Y equals negative 2, but instead of x, I put the 0 right in there, minus 3. So y equals, that cancels out, negative 3. So my answer to the system is 0, negative 3. I'll be honest with you, substitution, all this work that I just did, was totally pointless. Why? Because these two equations are both in slope-intercept form. Okay? They're both in slope-intercept form. Let's think about that. Let me do a quick sketch here. Let me just put a quick xy plane. And I know that this top equation, if I were to think about this as graphing, it crosses at negative 3, and it goes up 6 over 1. So there's my top equation, right? And the other equation, let's graph it in blue, crosses at negative 3, same exact spot, but it goes down 2 over 1. So as you could see, they share that point, that they have a common b value. You see, there's a b value of negative 3 and the b value of negative 3. So we know they're going to both cross the y-axis at negative 3. So I didn't really have to do any work. I could have just thought of the graphs and recognized that they both have the same b value, which means that they both cross at the location 0, negative 3, which is our answer. Pretty cool, huh? So why did you show us all this work on substitution? Well, I don't know. Maybe you're bored on Saturday night, lonely, right? Might as well just do substitution, even though you could think of the graphs. Anyway, moving on. Number 7. So far we've learned two methods, substitution and graphing, and it's a good idea to just think about which method is better for you, which is a quicker method to do. And if they are both set up in y equals mx plus b like number 6 is, you might as well use graphing, especially if you have the same b value or the same m value. Number 7, pick an equation, solve for a variable. Okay, so I'm going to pick the bottom equation and I'm going to solve for x. So I'm going to get rid of the minus 2y by adding 2y. And I will have x equals 2y plus 4. And then, once you have the variable equaling this stuff right here, I'm going to take that and plug it into the equation I have not used, the top equation. Plug it right into the x. So when I plug it in there, it's going to say 3, but instead of x, I put parentheses, and then plus 4y equals 2. So in the parentheses, I'm going to put 2y plus 4. And then it just becomes a question of solving this equation. And you solve by distributing and combining like terms. Let's distribute. 3 times 2y, 6y. 3 times 4 is 12. Bring down the plus 4y, bring down the equal sign, bring down the 2. Then you look at those 3 terms on the left side of the equal sign, and you could actually combine the 6y with the 4y. So $6 plus $4 is $10, but in this case, y's. So I have 10 y's, and let me bring down the rest. The plus 12, bring down the equals, bring down the 2. I need to solve for y, so I need to subtract 12. Subtract 12. I will have 10y equals negative 10. To get rid of that 10 times that's in front of the y, let's divide by 10. Divide by 10. Y is going to equal negative 1. I have one answer. I need the other. I'm going to plug it back into any equation I want. I'm going to go for the bottom equation. So I'm going to take this negative 1 and plug it right into the y, because y equals negative 1, so I plug in the 1 right into the y. Let me rewrite my bottom equation. X minus 2y equals 4. And I'm going to put the negative 1 in place of the y inside parentheses. So I really have negative 2 times negative 1. That's really going to be x plus 2, because that's a positive 2, equals 4. And then we subtract 2, and we have our final answer, x equals 2. So our answer to number 7 is the coordinate 2 comma negative 1. That's our answer to number 7, 2 comma negative 1. Of course, if you have time, plug in your x value of 2, plug in your y value of negative 1, and see if you can double check it with both equations. Number 8, pick an equation and solve for a variable. I want to pick obviously the top equation and solve for x. It's already done for me. Step 2, take the variable expression. X equals what? X equals 2y. So I'm going to take that value of 2y and plug it into the equation I have not used right into that x position. Once again, if it would say y equals something, I'd be plugging it into the y, but it says x equals something, so I'm plugging it into the x. Let me rewrite the bottom equation. I'm going to rewrite it negative 2x, but instead of x, I'm going to put parentheses. Negative 2 parentheses plus 4y equals 6. And we said we're plugging in the x value of 2y. So 2y right in there. Now let me do the math. What is negative 2 times positive 2y? That is negative 4y. And then I bring down the plus 4y and the equals and the 6. And now I could combine like terms. And if I combine like terms, negative 4y plus 4y, that's 0 y's. In other words, they cancel out, they disappear. So you end up with nothing equals 6. Nothing equals 6, 0 equals 6. What do we say about that? We say no, that can't happen. What do I mean by no? I'm talking about no solution. Whenever something impossible happens, like 0 equals 6 or 3 equals 4 or something like that, it's impossible, you say no solution. Now, if I were to have rewritten this standard form equation in y equals mx plus b, like if I wanted to graph it, and I rewrote this one in y equals mx plus b, and I actually graphed them, I would notice that both lines are parallel. Both lines have the same slope, which means that they do not intersect, which means that there is no solution. If I asked you to classify this system, it would be an inconsistent system. Let's try the last one. Substitution method. So I'm going to pick an equation. Which one is the easiest one to pick? Obviously the top one. Why is that? Because it already has y by itself. So all I need to do is take this and plug it into y. So my new equation is going to be x plus, but instead of y, I'm plugging in the x plus 2. And then equals 6. Do I have anything to distribute? No, there's nothing there. So if I want, I could pretend it's a 1. 1 times x is x, positive x that is. 1 times 2 is positive 2. So in other words, the parentheses just disappear. The x comes down, the equals comes down, the 6 comes down. Then we combine like terms. x plus x is 2x. Bring down the plus 2, bring down the equal 6. Now from here I'm going to subtract 2, I'm going to have 2x equals 4. And to get rid of the multiplication of 2, I'm going to divide by 2, cancels out, x equals 2. Ladies and gentlemen, that is one answer. I still need the other. Remember, your answer is going to be a coordinate, an x value, which in this case is 2, comma, and a y value, which we need to find. So all I need to do is take the x value of 2 and plug it into any equation I want. I usually go for the easiest route, which would be plugging it in, the 2 right here. 2 plus 2 is 4. I already know my answer is 4. But just for kicks, let me show you. I could take this 2 and plug it in to the other equation, the harder one. That would be 2 plus y equals 6. And of course, you subtract 2, y is going to equal 4. Y equals 4. So y equals 4. So it doesn't matter which one you plug it into any original one. Once you get an answer, you can plug it into either the top or the bottom. You're going to get the same answer anyway. There's your correct answer. If you have time left over on any quiz or test or homework, or if you're bored, you can take your answers and you could plug in the 2, plug in the 4, plug in the 2, plug in the 4, and it should give you, you could double check it to see if it works for both.